Hey guys, welcome back to another video. Today we're going to be looking at part 3, the last installment of the Chemistry Hack series, and we're finishing off strong with the last chapter in Chemistry Term 1, which is metals and nonmetals. So let me know in the comments if you enjoyed this series, and also if you want me to create a similar series for biology, physics, or any other subject. So without any further ado, let's begin. So the first hack is related to the nature of oxides, which is hard to remember in my opinion. So whether the oxides are basic or acidic. And it's already been defined through experiments in the past that all metallic oxides are basic, which means they have a pH between 7.1 to 14. And all non-metallic oxides are acidic, meaning that they have a pH level of 1 to 6.9. So for more information about pH, acids, and bases, watch the last video, which I'll leave in this card right here. And so yeah, metal oxides are basic, non-metallic oxides are acidic. This was determined as I mentioned earlier, there was some experiments, and they showed that metal oxides, when reacting with acid, form salt and water, and non-metal oxides, when they react with bases, form salt and water. So salt and water formation is also known as neutralization reaction. So if this is a base, then it would form this, and if this was an acid, it would form this. Therefore, it was determined that metal oxides are basic and non-metal oxides were acidic. So this also leads to conclude that metal oxides don't react with bases and non-metal oxides don't react. This should be acids typo right here. Just forget that. Metal oxides don't react with bases and non-metal oxides do not react with acids, because a base plus base wouldn't form anything new. Similarly, an acid plus acid would also not form anything new. So in one of my school exams, I took this picture right out of the exam file. I actually missed this question because I didn't know this basic underlying difference between metal oxides and non-metallic oxides. So these questions aren't related to the topic right now, but manganese oxide is what the question is. And manganese is, of course, a metal. So the question says, it's one of the case study questions. It said, manganese oxide with hydrochloric oxide is depicted in the following diagram. It was observed that a gas with bleaching abilities was released. Obviously, we don't need to know everything about this question, but this is the most important, this last one right here. So it says, in the above discussed reaction, what is the nature of MnO2? Acidic, basic, neutral, or amphoteric? And the answer, I really didn't know anything, so I just had to guess amphoteric, which we'll also be talking about soon. But the answer is, since metal oxides are basic, it should be option B, basic in nature. I missed a question, and I hope you don't, because I took the hit so you didn't have to. Next question, or next topic at least. While we're on the discussion of oxides, as I mentioned earlier, we will be talking about amphoteric oxides. That's spelled amphoteric oxides. And what those are, they're essentially these unique metallic oxides which show both acidic and basic properties, as opposed to only basic, and they react with both acids and bases. So normally metallic oxides only react with acids, but these special metallic oxides react with both acids and bases. And so, according to the curriculum and the textbook, we only need to know about two, which are zinc oxide and aluminum oxide. And these will be the only amphoteric oxides that you will be asked about in any exam. So that's somewhat relaxing. So aluminum oxide, as you can see here, it can react with acids like hydrochloric acid and bases like sodium hydroxide. So Al2O3 plus HCl gives rise to aluminum chloride, which is a salt, and water, H2O. And also aluminum oxide plus sodium hydroxide, which is a base, gives rise to sodium aluminate plus plus water. So this is a special compound that you should keep in mind, sodium aluminate. So that concludes amphoteric oxides. Now, reactivity of metals. So I already discussed this in the previous video, part 1, which I'll leave right now in the cards. So watch that previous video for the best mnemonic or abbreviation available on the internet that I found. So the reactivity series, go check this video out. Next, properties of metals. So there's a lot of properties that are difficult to remember. So the easiest way to remember these is through examples and applications. Real life applications, that is. And there's also a few shortcuts. So these are all of the properties of metals that you need to know about. Malleable, ductile, sonorous, good conductors, high melting point, and high density, and they are in the solid state. For each hack, we have a little something. So for malleable, we can break this word down to mallet, which is like a small sort of hammer. And with the mallet, we can pound it into thin sheets, and that's what the property is. Malleability is the ability of the metal to be pounded into thin sheets. For the next property, I really couldn't think of anything unique, but you can just remember that ductile means wires. So the property which enables a metal to be drawn into thin wires is ductility. And just think of this in this way. Malleable means sheets, ductile means wires. Simple, yet easy to remember. And it's also to the point. So next, the next property of metal is sonorous. And we can think of the prefix sono, which means sound. And the example or real life application of this is a school bell. Now these days, most of the bells are digital, but back in the day, they used to have these actual metal bells. And the thing is, when if you hit a metal, then it produces a ringing sound. Especially metals like silver and copper and a few other alloys. So when this bell rang, it would indicate that class is over or school is over for the day. And back in the day, at least, they used to use metals to form school bells because they're highly sonorous. So, high melting point, which means that it takes a very high temperature for metals to either melt or boil, so they can resist heat. And the best example to keep this in mind is cooking equipment. So all the equipment that we use, pots and pans, are all made of metals, either aluminum or copper or steel. And that's because they can resist heat. So even if we cook anything inside, then it won't burst into flames or explode. And while we're on the topic of cooking equipment, metals are also good conductors of heat, which means that they allow the heat to pass, but they also don't explode. And the cooking equipment, when we heat things over the stove, it's usually some sort of metal article that's used. And so while we're cooking, we can just heat it, and it'll conduct enough heat to allow the food to increase temperature while at the same time not exploding. Next, good conductor of electricity. And the example is all the wires around us are made of copper, which is a metal. And copper is one of the best conductors. But you may be thinking, if it's a good conductor, then when we should touch it, then we would get shocked. But if you look at any wires around you, if you're watching this video with wired headphones, or if you're charging your device, they're all covered in this substance. It's a form of plastic called PVC or polyvinyl chloride. and that's used to cover wires to enable safe touch, so that the current flows and the electricity passes, but I can still touch this charger right here, and I won't get shocked. That's why we use PVC. Next, metal reactions with water. It seems numerous and difficult to memorize, so any metal reacts with water, so it will be a metal plus H2O. And there's so many reactions, but in reality we only know the reactions of 6 metals with water: sodium, potassium, calcium, magnesium, aluminum, and iron. And if you look at this closely, these are arranged in order of the reactivity series. And that is for a specific reason, because the reactivity of the metal impacts how it reacts with water. So sodium and potassium, which are highly reactive, they can only react with cold water, and even doing so, they'll still burst into flames because it's a highly exothermic reaction, meaning that it releases heat. And calcium and magnesium, which are relatively lower in terms of reactivity, they only react with hot water. And lastly, aluminum and iron, which are basically, we're going really low now, they only react with steam. Sodium, potassium, cold water; calcium, magnesium, hot water; aluminum, iron, steam. And the products are simple. A metal plus water gives rise to a metal hydroxide and CO2 gas. So that concludes this video. I hope you enjoyed this entire 3-part series. And just let me know if you want more videos. And yeah, this is the Unconventional Tomper signing off.